On October the 10th, 1957, at the coastal town of Cumbria in the northwest of England, a fire alarm was raised. However, this was no ordinary blaze. It had already been burning for 3 days until visible flames were spotted and panic began to set in. This fire had started in one of 2 nuclear reactors at the Windscale Nuclear Weapons facility, a place so secret that the UK government had long used censorship and covert methods in attempts to prevent anybody identifying its function. Every worker and contractor had been forced to sign the Official Secrets Act. The non-military contractors were even told to drive to the hard shoulder of a motorway in the northwest, where they would be picked up and commuted to the facility, then back to their empty cars. Windscale was responsible for the manufacturing of plutonium and tritium, critical ingredients for the production of thermonuclear weapons. In the emerging Cold War that followed World War II, Britain was desperate to keep up with the United States and the Soviet Union, and millions of pounds was invested. Unfortunately, on that October day, 11 tons of uranium fuel were now alight, billowing masses of radioactive material into the air. Highly toxic iodine-131, cesium-137, and polonium-210 were freely floating on the wind across the north of England, the Irish Sea, and beyond. If the second reactor had caught fire, a core meltdown was likely, and uncontrollable radioactive material would quickly spread to the whole of the British Isles and mainland Europe. Most of northern England and Scotland would have remained a nuclear wasteland for centuries, unfit for human habitation. A controversial and entirely unproven method of flooding the reactor with water eventually put out the blaze. The damaged reactor was sealed and decommissioned immediately, entombed in concrete with its contents remaining deadly for at least 30,000 years. Now more than ever, there is pressure to find new and sustainable energy alternatives to fossil fuels all over the world. Alongside the renewables of solar, wind, and hydropower, the familiar shadow of nuclear energy remains an important element for any climate crisis strategy. Its low carbon emissions and reliable efficiency could be seen to make nuclear power an attractive investment in the future of planet Earth. But it brings with it one very important challenge, one that scientists, the military and the commercial sector has struggled with for the best part of a century. What do we do with the radioactive waste it produces? How can it be safely removed from the manufacturing process? And with radiation levels remaining active for hundreds, sometimes hundreds of thousands of years, how best can we be sure to warn our future populations of where this waste is, what harm it can do, and how to make sure it doesn't devastate the planet centuries after it has been used? There are many buildings all over the world so shrouded in secrecy for their true purpose that most of us will never get to know what really goes on between their walls and extremely guarded surroundings. However, when the contents of these structures are deemed to be a matter of national security and may threaten the way of life across the entire planet, then those in power are forced to divulge information to the general public. Official reports have linked the incident at the Windscale Nuclear Weapons facility to around 200 cancer deaths in the nearby area, although it could be many more. The effect on the landscape was catastrophic. Crops were destroyed, and thousands of liters of milk from the area was deemed unfit for human consumption in the aftermath. The truth was that nobody could say for certain what the effects of this radioactive waste were. The secret was now out, and the world began learning some terrifying lessons about the extreme long-term planning that nuclear power requires for its production, maintenance, and ultimately its waste. It was evident that the rush for atomic energy was going to have extreme consequences for our planet for millions of years. The Windscale facility was eventually renamed Sellafie in 1981. This was an attempt at a rebrand to exorcise the ghosts and memories of the fire. It switched to providing energy for the national grid until 2003, when the ailing 50-year-old facilities made it far too dangerous to continue and much too expensive to upgrade. The site at Sellafie is now more like a small town of over 200 buildings across an area of around 2 miles. Almost 12,000 people work there on an ambitious mega-project that will continue for at least the next 100 years at a projected cost of around £131 billion. It is perhaps the deadliest industrial site in all of Europe due to the levels of radiation that resides there. Unorganized waste in temporary structures, some even open to the elements, is decaying at a glacial rate, and the measures to protect the environment from them are failing much faster. This is the world's most monumental decommissioning project. It is terrifying, dangerous, and full of unknown elements and challenges at every step. Understanding exactly what waste there is becomes the first problem. The first issue is referred to as legacy waste, dating back to the first operations in the 1940s and 50s. The Magnox storage ponds are open-air water-filled silos that were always intended as a temporary storage solution. Inside these ponds are spent fuel rods, radioactive sludge made up of debris, corroded metal, and particulate waste, alongside discarded tools, clothing, and parts of the facility's structure that have fallen in the pond over time, immediately becoming radioactive. Most of this waste is unrecorded with no records to detail the volume and type. While it remains there, it presents vulnerability and danger on an unimaginable scale. The structure of the ponds themselves is a 70-year-old concrete edifice that presents a huge threat from deterioration and leaks. So, as the ponds are emptied, these must also be carefully decommissioned. With increasingly unpredictable weather, there has been a decades-long risk of these ponds becoming overwhelmed by rainfall, spilling disaster all over the site and into the atmosphere. Close proximity to these ponds, even for short periods, would be extremely dangerous, so the cleanup work is carried out remotely with underwater robots operated on-site from screens and controllers. The sludge is pumped from the pond floor, and highly radioactive items are grappled and transported into new specially built storage facilities. All of the waste in Sellafie is categorized into high-level waste or intermediate-level waste. HLW generates immense heat and radiation for around 300 years before remaining toxic and dangerous for thousands of years more. As an example, the isotope technetium-99 has a half-life of 211,000 years and remains a hazard for over 1 million years. This HLW has to be temporarily stored as a liquid in stainless steel tanks. It can then undergo a process of vitrification that evaporates any excess water, mixes the liquid with glass, forming minerals, and solidifies into a molten glass that can be secured in sealed and durable containers. This process takes days for each relatively small batch of waste. Intermediate-level waste is encapsulated into concrete or stainless steel containers, then stored on-site at newly built facilities that are safe to hold them for around 100 years. But this is yet another intergenerational and temporary solution. Interestingly, the time period required here has thrown up its own unique challenges. With no real way of knowing what platform or media these records may be read on in the future, an altogether more traditional media is required. The waste records are stored on the highest quality archival paper that will stay free from the obsolescence that digital platforms are prone to. It also allows for an all-important backup, Recent investigative work has suggested that Sellafie was the victim of a long-term cybersecurity attack from bad actors. Malware was found that had laid undetected on the IT infrastructure for 8 years. The impact of weaponized radioactive waste is clearly a high priority to constantly address while the decommissioning process is carried out. All of this means the race is now on to create a massive geological disposal facility within the UK to deliver a permanent home for all of this devastating material. Plans show it will be an underground repository 1,000 meters below the surface within stable rock formations of clay, granite or salt. Construction is expected to take at least 20 years for a site with around a 20 square kilometer footprint. And even the most ambitious timeline doesn't have it ready until at least 2050. Although the exact location is yet to be chosen, there will have to be a huge public information exercise to ensure confidence from any nearby communities. One of the most important lessons learned from the UK's own nuclear program is that complete secrecy can often be counterproductive, as Windscale and Sellafie illustrated perfectly. The burden of being a relative pioneer in the production of nuclear energy is only now becoming truly evident for the United Kingdom. International eyes will definitely be monitoring the situation and hoping that the cleanup project remains steady and safe. As the disasters at Chernobyl, Mile High Island and Fukushima have all demonstrated, the fallout of any accidents at these facilities is very much a global concern. Decommissioning Sellafie is now an ongoing case study in how to manage one of the most important elements of nuclear energy, the incredibly dangerous potential of the waste it produces. If there is to be a renaissance in the use of nuclear power and a pivot towards the creation of more nuclear plants, then long-term safety and storage of nuclear waste must be at the top of the list of risk assessment. The short-sightedness of safety in the atomic age is now beginning to come into sharp focus. And this inherited responsibility of cleaning up after the generation before must not be allowed to happen again. The eerie clock-like ticking of dosimeters at Sellafie serves as a reminder that when it comes to nuclear energy, there is always a lengthy timescale to consider.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching and see you in the next one.